Welcome! In this project, I will show you how to make a simple game where you go around the screen collecting things in Python. And just as an example here, so in my game that I've built here, the backstory is that Mario was off asleep and forgot to collect all of the moons, and so Princess Peach thought that she'd just go and collect them herself. And the idea is that there are two moons at a time, and you should collect the closest one because that's the easiest one to get. And it just keeps track of how long you've taken and how many moons you've collected. So super simple. Your one doesn't have to have the same backstory or images or idea, but I will show you how to do the code where you can collect things on the screen, and I'll show you how to do a timer and how to keep score. Okay, let's get into it. For this project, we will be using a free online tool called CodeSculptor 3. This is not something you would create a professional app with, but it's a fantastic way of learning. It's a simple web-based Python coding environment that's ideal for creating basic graphical Python programs with a GUI interface. And what we mean by a GUI, a graphical user interface, is when we hit run, is we have a window and we have buttons we can click and we have a canvas that the program can draw to. So let's have a quick look at CodeSculptor 3 and how it works. So first of all, just so you know, if you hit save, it will actually change the URL at the top of the screen. You can't see it here, but you'll see on your computer. And what you need to do is once you've hit save the first time is you need to bookmark that page. So if you click on the star in the address bar, that will create a bookmark for you, and then you can go back to your project anytime you like. Every time you make a change and then you hit save again, it will actually keep the same address, except the last number will change from a 0 to a 1 to a 2 to a 3, and so it will actually keep all of your different versions in there of your program, so you can go back to previous versions if you like. If there's something that you don't know how to do in CodeSculptor 3, it is very well documented. If you click the docs here, it will open up, and if you go to graphics modules and canvas, those are most of the things you'll probably want: how to draw text, how to draw images, etc., etc. But definitely this graphics module section is the one that you want. Now, a graphical user interface is not something that's built into Python directly. So you'll see here in this little example program that is up on the screen when you go to CodeSculptor 3, you actually have to import Simple GUI. And if you go on to make other GUI programs later, you'll probably use a different library that will work a little bit differently. But this is a really nice, easy way to get started. Let's have a look at this example program here. If I click Run, it says welcome, and when I click on the Click Me button, it changes to Good Job. So I'm going to go through this step by step just to have a quick idea of roughly how GUI programs are set up, because it's a little bit different to a command line Python program. So first, you can see here we've imported Simple GUI, the library, then we've just created a variable and called it welcome. Now keep in mind that does not draw it onto the screen or anything like that. It's just stored in the machine under the name message. Now, what we have here are two functions. One of them is called click, and it doesn't have to be called click, but this function is basically what runs when you press this button here. And then the draw function is what runs 60 times a second when your monitor is ready to redraw or to refresh. Now, those don't automatically happen on clicks and draw. That's what this next section is, which is setting up the frame. So this is the frame. So frame, we've just called it frame. We could have called it my frame or window or something like that. It's up to you, but we've called it frame here equals simplegui.createFrame, so that'll create the new frame for us. The first parameter here is what it's called in the top left-hand section there. Then we have the width and the height in pixels. Now the next thing that's done in this program is they've added a button onto the frame. This is what it says on the button, as you can see here. And this is the function that will run when the button is pressed. So I said this didn't have to be called click. You could call it button press or something like that, as long as you put the same name in here. Then we have to tell Simple GUI which function we want to run 60 times a second, and we've told it that that's the draw function here. And then the final thing that's happened is we start the frame. So this behaves a little bit differently from a text-based command line Python program. Basically, all of this setup happens pretty much instantaneously, and then all the code that gets run after that point is in these functions that we call them callbacks. So the program actually calls back into our code when either a click happens or the screen is ready to draw. So you can imagine every time there's a click, this function will run. Every time the screen's ready to redraw, this function will run. And another word for this is event-driven programming. So it's basically the idea that these functions run when certain events happen within the program, whether it be a button click or user input or the mouse moving or something like that. It's a little bit of a different way of thinking about things, but you will get used to it after a period of time. I don't need this variable, the message variable. I'll get rid of that. I don't need the handler for the mouse click, so we'll get rid of that. We'll keep the draw function, but we'll get rid of what it does inside. Now you can't have an empty function in Python, so I'll just hit, say, pass. We also don't need the add button there because we don't have a button. And now we're left with all of the stuff that we will use. So then basically creating a frame, that creates this thing here, a frame. And so we've called it home. I might change that to game, and I might we'll do 900 by 700. And now if I open that again, you'll see that it is bigger and it says game up the top there. Although I think 600 might make it fit on my screen a little bit better. There we go, much better. The first thing I'm going to do in my project is get the main character on the screen and moving around with the arrow keys. So I've done a Google image search here for Princess Peach cartoon. So I did a Google search and then I clicked on images. And again, please don't feel like you need to select the same character as me. You could have anything that you want the main character to be. It could be a frog, a lamppost, whatever you want to do. I want to absolutely make sure that there's no white box behind the player. I want it to be a transparent background so it'll look realistic. So I'm going to click on Tools, Color and Transparent. And I think this is the picture I used, so I will click on that. Now, you shouldn't be able to see the checkerboard on the background here, but if it's white on the background here and then you see a checkerboard background here, it means that it is a real transparency. Sometimes they're fake transparencies. And if I right click on here and click copy image address, then if I open it up in a new tab, you should be able to see the image in a new tab, and you can see it ends in PNG. Sometimes, occasionally, it'll be in a weird format that won't work with Code Sculptor, so you might have to try a few times. Now here we are back in Code Sculptor, and it can be a little bit tricky to get images working, so let's just focus on getting the picture up on the screen in any way, shape or form first, then we'll try and make sure it's the right size and all that sort of thing. So how do we get the picture up on the screen? Well, we need to actually up here make a variable that we're going to store the image in. And so I'm going to call this peach image. And we need to, there's a function that will load the image in for us. Now, in case you're wondering how to find these sorts of things, I want to show you it's all in the documentation. Let's just Control V, paste, and I'm going to put talking marks around it as well. Let's paste that link so that we don't lose it there. So there's the link. And I'm going to go to the docs here to find out what the function is that loads the image. So I'll go to docs. And we want to go to the graphics module. And there should be something here for images. Okay, so it says an image must be loaded before it can be drawn. So let's click on loaded. Okay, here's an example. So it's got a whole code example with a whole program here that you can use. But the part that we want is this simple GUI.load image and then the URL. I'm just going to copy this bit up the top. So Control C and then Control V, and this is the URL down here. Okay, and then passing that as a string of letters, a string, which is needs to be in talking marks. So that should load the image, hopefully. Now we won't know if that's worked until we draw the image. So we want to draw the image in our draw function here, because remember when we made our frame, we're setting the draw handler, which will run 60 times a second roughly, to the draw function. So how do we draw the image then? Well, let's go to the docs again. And to graphics modules, I would leave this open in another tab, honestly. Images, and then it says image must be loaded before it can be drawn. So let's click on drawn. So draw image. Here's an example. So we have the function is called canvas.drawImage. We have the image name that we saved in a variable, the center source, the width height source, the center destination, and the width height destination. Okay, what on earth does that all mean? Well, let's see if we can get it drawn up onto the screen, and then I'll explain those things in a bit more detail. So I'm going to copy this, Control C, and I'll go back to the program, and we'll paste that code into here. Okay, now, just to be clear, this is going to run 60 times a second to draw it up onto the screen again, okay, and then it'll get wiped and this function will run again. That's how it works. The image here is the name of the variable that we saved the image into when we loaded it, so peach image. Okay. Now, this was the center source, and you can see that actually this is it's hard to see here, but this is what we call a tuple in Python. So a tuple is basically, it's like a list that can never be changed, an immutable list. That doesn't really matter, but just know that, think of this as a bit of a list. And this will be the X position and this will be the Y position. And it's asking you, so for 4 of these tuples. So let's have a discussion on what it means. So the first one here is asking us for, well, let's look at the second one. So the second one here is asking us for the width and the height of the original image. So let's go and have a look at that. So over here you can see it actually says 680 times 678. And that means that the original image is 680 pixels wide and 678 pixels high. Now, when it's asking us for that, you might say, why is it asking us for that? It already knows that information. But if we put 300, for example, it would only draw 300 out of the 680 pixels of our image. So it's basically saying, what width and what height of the original image do you want to draw? We want to draw all of it, so we're going to put 680 times 678. So let's go over here. 680 and was it 678? I hope so. The second thing, or the first thing, that was the second thing. The first thing it's asking is, where do you want us to have the center of what we've drawn? And I actually want the center of that image to be the center of the image. So let's go here and say 680 divided by 2 would be halfway across the X there, and 678 divided by 2 would be halfway up and down. Now these have to be whole numbers, so if we do 2 slashes in Python, that means the answer will be a whole number, okay? Now, I'm just going to go and explain these two in a little bit more detail. So let's imagine this is our picture. And the first question is asking, how wide do we want to draw and how high do we want to draw? And you might say, that's easy. We want to draw 680 wide and 678 high. But maybe we don't. Maybe, in fact, we just want to draw this part of the image, right? Okay. And in that case, then perhaps the width of that part that we want to draw, I'll make this a bit smaller, maybe that's only 236 pixels, for example. And maybe the height of what we want to draw is only 400 pixels. Okay. All right. That was the second one, is asking how much width and how much height we want from the picture. The second one is asking what do we want to consider the center of the picture? Now we just said 680 divided by 2 because that would be smack bang in the middle here, right, like there. And 678 divided by 2 would be smack bang in the middle because we want the center of our picture to be in the middle of the original picture. But we might want it to be over here, for example, if we're drawing a different section. I hope that understands why they're asking us for all of this weird information that they already know. So we've got those two sorted out. Now the second two are kind of easier. Basically, the first one here is how wide and how high we want. Oh, I'm going to get this the wrong way around. Let me double check in the docs again. So we go to graphics modules, images, draw image. Okay. So the width and the height, so the center of the destination and the width and the height destination. Okay, so center destination is first. Okay, so the first one here is the X and Y position that we want it to appear on the screen. So if we hit run now, you'll see that it is actually, if this is 0, 0 in the top corner here, X gets bigger as we go along here, and Y gets bigger as we go down on Code Sculptor, on Simple GUI. So this is at 50, 50. So if I was to make those numbers bigger, it would get pushed further out here. So let's say I was to say I'll put it at 150 and 350. That means it's 150 out this way and 350 down, so we can control where we draw it. And the final thing here is how wide and tall we want to draw it on the screen. So I've got 100 and 100, and that seems pretty reasonable. Let's have a look what I did on my original project. Yeah, in fact, I think I had 100 and 100, but you could make that bigger or smaller as you wish. Okay, I know that seems like a bit of an ordeal, but once you've done that the first time, for the other ones, it will be much, much easier. So we have our main character image on the screen, and the question is, how do we actually get it to move around on the screen? Okay, well, the first step for that is to realize where we control where it's drawn on the screen. And that is this one here. So right now it's being drawn at x equals 150 and y equals 350. Now just remember that means we started 0, 0 up here, x 150, y 350, y goes down, okay? And that's common for a lot of programming environments. It's not quite like mathematics, like the Cartesian plane, it's a bit different. Okay, so the first step is to actually make some variables here in here. So we're going to, up the very top here, make a variable called peach x, and we'll set it at the moment to maybe the middle of the screen. So that would be, for me, that would be 450, and peach underscore y would be 300. Now you could call it player x, player y, if that makes a bit more sense for you. Because actually I might do that because your one's probably not going to be Princess Peach. So I'll just say player X, player Y, and I might change mine from Peach image to player image. Oops. Don't ever be afraid to go back and tidy up your code and improve it as you're going. Okay, so what we want here is we don't want to always draw it at 150. We want to draw it at whatever player underscore X is and player underscore Y is. And we'll just check that that works. Okay, that's good. That's in the middle. Now, I'm just going to check if I change this to 150. Yes, Peach has moved. But obviously, we don't want to move the character by changing that variable in the code. We want you to be able to do that with the arrow keys. So how do we get arrow keys? Well, what we do is remember we talked about these event handlers? We basically make a function that runs whenever a key is pressed, any key on the keyboard is pressed, and whenever any key on the keyboard is released, we also run this function. So let's go into the docs and see if we can find this. So again, we go into our graphics modules, and I think they're control objects. Let's have a look. Here we go. Yes. Keyboard input handler. Okay, so we have two functions here. We have, and I'm going to want both of them. And I'm going to paste them here. Now, just to be clear, all of this code runs once at the start of the program, and it basically sets up what functions get called when what things happen. Okay, so when the screen's ready to draw again, it'll call our draw function. When it detects a key down event, a key being pressed on the keyboard, it'll run these. So I'm going to call these slightly different names. I'm going to call these key down and key up. And let's make those functions now. Let's just call these event handlers. Now this is just a comment, it won't change how anything works, but that's just for me, so I'm a bit more organized. So let's define key down. And I think key down gets passed, basically it gets given the number of the key, and that'll be stored, whatever you type there. I suggest key, but you could type Tony or Sarah or something, it would still work, but that means that this variable with that name will be given the number of the key that's been pressed. Let's test this out. I'm just going to say print key, and let's run this. Oh, I haven't. It's not going to let me without making the key up function. And I'm going to leave this one. Actually, let's do the same thing with that one. Key up function as well. Okay, so I'm going to move this out of the way. Now I'm going to press the left arrow key, and you can see I'm holding it down. You can see over here it says 37. Okay, now I'm going to press the right arrow key. It says 39. I'm now going to release the right arrow key. It says 39 and 37. So you can see here, I can find out the numbers that these keys are getting when they're being pressed. Okay. Now, what we're going to do is, I think the best way to handle this is I'm actually going to show you the code that I'm doing for the movement, and then I'm going to explain it. Okay. So let me copy and paste it in, and then I'll explain it. Okay, so I've copied and pasted some code. I'm just going to go through it with you one step at a time. So I've made three variables. One is the player speed, which is how many pixels per frame I would like the player to move up and down and left and right. Now you can play around, you don't have to use 5, and you can change it at any time. The second one here is a player x velocity. That's how many frames per second they're moving left or right. So if it was 2, that would be 2 frames every, 2 pixels every frame to the right. If it was -2, it'd be 2 frames to the left. And the final one's a y velocity. So could you copy and make sure that you type out those three variables because those are what we're going to need. Okay, hopefully you've done that. This is a little bit tricky, but we'll get there. The next step is in our key down handler, we're going to change the x velocity and the y velocity of the player when there's a key down or a key up. Now, to do that, I need to type in global and then the variables separated by commas that I'll be changing. What that basically means is go out into and get these global variables which are not inside this function and make it so that we can change them inside this function. That's all it means. Now, if key equals 37, that's the left arrow, we are going to decrease the x velocity because we want it to go left in a negative direction by player.speed. Okay? The other ones are just the same for the up, right, and down keys as well. Okay? So basically, I think the best way to demonstrate this is if I do a print, I'm going to print player xvel, and over here in the output, you can see if I run it, the speed is 5. So if I run this now and I press left, oops, you can see now the speed has been put to -5. Now, if I lift up the left arrow, I want it to reverse. I want the x velocity to be increased by 5 now, so it's back to 0. Okay? I'm not going to explain it in full detail. I'd like you to copy this out and have a bit of a play around with it and convince yourself that it sort of makes sense. But the idea is when we press up, or when we press down, we will increase the speed that we're going down. When we release down, we will slow down the speed that we're going down. Okay. Now that doesn't change the player's x position. So the final thing that we need to do is if we go into the draw function here, 60 times a second, oops, then 60 times a second, we want to say, well, the player's x position, we're going to add onto it whatever the player's x velocity is. So if it's -5, then 5 will be taken off this every frame that's the case, and it will move to the left. Y is, of course, up and down. And of course, we'll also have to say, hey, we want to change player x and player y inside this function. So just so you know, we want that global variable. Now you might say, why don't we need to do global for the player xvel and the player yvel? That's because we're just reading those values. We're not changing them. We only need to put this at the top of the function if we plan on changing some global variables. It's a bit of a safety feature, really, to stop us accidentally changing these when we don't mean to. We're going to show you how to get a nice background image for your game. And not just that, but also make it slightly darker than the rest of the game so that it doesn't interfere and the foreground really pops out like this. So I've done an image search for a Mario background, but obviously you should choose a background picture that suits your game. And it should be probably predominantly dark colors, not completely white, because even if we darken it later, it won't really work very well. So this one I think will be okay. If I click on it and then I right-click and copy the image address, I can then come back and add it to my program. Now you'll remember that there are two aspects to getting an image on the screen: loading it and displaying it. So underneath where it says player image here, or actually I might do mine above, I will say background image. Now that's just the variable name I chose. You could choose a different name. Equals, and this is going to be much easier than last time because we don't have to look up how to do it. It's here, simple GUI.load image. Put some quotation marks because it's a string, and then quotation marks to finish it, and close the bracket there. Okay. So now we have it loaded, hopefully. I'll just run that, and it seems to have no errors, so that seems to be a good thing. So how do we draw it? Well, in our draw function here, let's put some comments. This is draw the player. And we want to draw the background actually before we draw the player. Otherwise, the background would be drawn on top of the player and we wouldn't be able to see the player. Okay, I am going to just copy this code here, Control C, Control V. Okay, and then instead of player image, we will do background image. And instead of the dimensions of the player image, we want the dimensions of the background image. Now, instead of putting in the actual numbers and going on to Google and looking them up, there's an easier way of doing it. Instead of 680, we can get, I'm just going to make two little variables in here called width and height, but I'll just call them W and H because I'm being lazy. We can set the W, I just made up that name, but we can set W to background image dot get width. So this is a function that will return the number of pixels it is wide. And the height is the same thing except get height. And that's on the documentation if you want to go and look at it, but I won't waste time now. So let's just print W and see if it matches up. So if I hit run here, it says 1600 and it's printing that 60 times a second because it's in the draw function. Let's go check if it is actually 1600 wide. So if I go back here, you can see, yes, it is actually 1600 pixels wide. So that's a bit easier. So then in here, all I have to say is, instead of the width and the height, I can just put W, H, W, H, and we want to draw this in the middle of the screen, which will be, for me, 450, that's half of 900, and 300, I think. Well, we'll find out if it's wrong pretty quickly. That's the middle. And how wide and how high do we want it to be? Did I get these the wrong way around? We'll find out soon too as well. So we want it 900 wide and 600 high. Let's see if that works. Okay, that actually works perfectly. So I must have got them right. Okay, so yours will look very similar to this. And in fact, because we're automatically finding out the width and the height, you don't have to even go and track down and see how big it is. Okay. Now there's one more thing I'm going to add here just to protect us a little bit. And that is, if the image hasn't loaded yet on the first or second frame of the program, the game will actually crash if W or H is less than 1, okay, or 0 or less. And we don't want the game to crash, we just want it to not be displayed for a couple of frames till it's loaded. So the way that we can do that is we can say that we only want to draw this image if the width and the height are greater than 0. So we'll say if width is greater than 0 and H is greater than 0, then draw this, okay? Now I'm actually going to also make this change to the player. So I'm going to copy all of this code here and paste it here and replace this with width and height and width and height. And that way, if the player doesn't load, image doesn't load, that should work as well. And that's not working because clearly I have made a mistake somewhere. All right, let me double check that. Oh, oops, silly me, sorry. This should be player image. And this should be player image. Okay. All right, so I'll just drag that across, you can see all of that code and check that you have the same code, except your images will be different than mine, obviously, but hopefully you have that all working. And if we hit run, it's all working. So the second part of this is how do we get it to be darker? And what we're actually going to do is we're going to draw a big rectangle over the top and fill it in with imagine like a slightly dark film over the top. And let's do that. So you can find this in the documentation, but I'm just going to save you a bit of time. I'm going to show it to you on here. Okay, so I'm going to copy and paste this as one line of code, and we'll run it, and you'll see that that's made a really nice dark polygon over the top. And now I'm just going to explain the line of code here. So Canvas has a function called draw polygon. A polygon is just a shape that has multiple points, so a triangle, a star, a rectangle, etc. And the first thing that you need here is a list of lists, and each list in here has 1 point of the polygon. So 0, 0 is top left corner, 900, 0 is top right corner, 900, 700 is bottom right, and bottom left. So those are the 4 corners of the shape, okay? This here is how wide you want the border to be, which is irrelevant because we're making the border invisible, so that could be whatever. Now, this is the color of the border. Now, RGBA means red, green, blue, alpha, and alpha is how strong it is and how opaque it is. So an alpha of 1 means it's fully there, an alpha of 0 means it's transparent. So if this is 0 here, that means that the border color is transparent because we don't care about the border, okay? This is the same thing, RGB 000. If you have 0 for red, green, and blue, that's black color, but the alpha is 0.5, so it's only half of the black is coming through. So you can play around with this number here. For example, if we were to make it 0.9, it would almost totally cover up the background, like it's sort of nighttime. And if we were to make it 0.1, then it's hardly going to darken it at all. So for mine, I'm going to go with 0.5 because I think that's a good balance. We're going to look at how to get our collectibles working. So for my case, these will be the moons, but for you, it might be something completely different. So the first step here is to load the image. Now, I'm not going to go and show you me looking for a link on the internet again, because we've done that several times, but just remember you need to click on copy image address, and oops, I've got 2 of those now. So I'm going to load the image in, moon image, and again, I've just made up this name of this variable, but we are loading that in. The second part of it is drawing it, and how we do that is we go to our draw function, which is here. We have to decide whether it's going to be in front of or behind the player. I think in front of the player, so drawn after probably makes the most sense. So I'm going to say draw moons, but you call yours whatever you happen to have. I'm going to copy and paste this code to make it a little bit easier for myself. And this will be moon image. This will be moon image. Okay. And we will again say moon image here. And we need to decide where we want to put it onto the screen. Now, with the player code, we had player X and player Y. So I probably want a moon X and a moon Y. But I'm going to say moon1 underscore X and moon1 underscore Y. That way, if I decide to have a few moons, it will make more sense. So moon1 X, moon1 Y. And the size of it, let's try 50 pixels by 50 pixels. I'm not sure if that's what I did. Let me check. Yes, 50-50, okay. So I need to then go up and create some variables for the moons here. So we'll say moon1 X equals, for the moment, I'm just going to put them in the top left corner. So we'll say maybe 100 x and 100 y. And let's run that, see if it works. Oops, no, we've got an error here. What does it say? Name moon1y is not defined. Okay. Okay, maybe we actually, in this case, have to. Let me just check to see if we need to define them in the global. That might be the case. Even though we're not changing them, I have had this in the past. Oh, no, let me double check. Oh, no, that was the case. We did need to, but also I made a mistake here. That should be moon1. Okay. Okay, and there they are. They're on top of each other. Oh, so no, sorry, that's just one at the moment. So there it is. The second thing that I would like to do is actually make it slowly rotate. So if I say moon1 underscore rotation, and we'll set it to 0. Now, I don't believe this is in degrees. I believe it's in radians. So instead of 360, I think it's twice pi radians around, so 6.28 roughly. But that doesn't really matter. We can just play with the numbers till it rotates at the speed that we want. Where we draw it here, we're going to need to use that variable in here as well. So let's add that moon1 rotation. And then when we draw the moons, we can actually add on at the very end here the rotation. Otherwise, it's presumed to be 0. Okay, there we go. But we also need to actually rotate the moon every frame. So we'll say moon1 rotation plus equals just a very small amount, 0.05, we'll say that. And as you can see now, the moon is rotating around. Okay, so just to go over what we did there, we made a moon1 rotation variable. We slightly increase it every frame up here, and then we add it onto the very end of our drawing variable. Okay, so now that we've got one moon, I think we actually want to have 2 moons for this particular project. So I'm just going to repeat everything here. Now, if you want lots of moons, there are some clever ways you can do that with classes and things like that. But for the moment, we'll just keep it simple. So I'm just going to copy that and change all of these to a 2. So this is moon 2. And then we'll also need to import those into here. Maybe we'll rotate moon 2 at a different rate, so 0.03, just to make it look a bit different. And then I will copy all of this. All of this. And actually, I won't need to redo this because this will be exactly the same, because the image will be the same. In fact, I can just put it like this, because all we need to do is just draw the second one. So this will be moon2.x, moon2.y, and moon2.rotation. Okay, and let's put this one in a different place. So I'm going to say 200 and 200. And there they are. So the next step in our game is to detect whether we're colliding with the moons and be able to, for example, reset them, increase the score and things like that. How are we going to decide whether we're colliding with them? I think the simplest way is just to do a simple distance function. So if the distance between the center of our player sprite and the center of the moon sprite gets below a certain amount, we can play around with it and see how it works, maybe 50 pixels or something like that, then we consider it to be a collision. So let's look at how that sort of would work in the real world. So imagine that you've got the P, we'll just say P for player here, and then we've got the moon. I'll just put moon here. So the center of here and the center of here, how do we work out what that distance is? So if we turn it into a triangle, we can actually use Pythagoras' theorem to work out the distance. And if you're not very confident with mathematics, don't worry, you can just copy what I'm doing, but hopefully it's very interesting how we can actually apply things like Pythagoras' theorem into our game to get it working. So just a reminder of Pythagoras' theorem, if we take a particular side, A and B are the shorter sides, and the hypotenuse, the longest one, is C. And Pythagoras' theorem says that, I'll make this a bit bigger, says that a squared plus b squared equals c squared. I don't actually know how to do squared on here, but that's okay. Let's actually use the Python way of doing that. So that's how you do it in Python. 2 of these symbols means to the power of, these stars. So a squared plus, actually I'll do lowercase, equals c squared. Oops. So what we're interested in is the distance will be c. So we will know the difference between we'll know A and B because, okay, let's say this is the player up here. Oops, I've got a brush. Let's say this is the player here at this point, and this is the moon down here. We know the x position of the player. So let's say it's at position 50. If the x position of the moon is 20, then it's going to be 50 minus 20, and we'll know that this is 30. So we'll be able to tell that. Again, if we knew that the y position was, let's say, I don't know, 100, and this one was 120, the difference here would be 20. And it doesn't matter whether it's negative or positive because we're about to square it, so that'll get rid of that. Negative 20 squared is the same as 20 squared. Okay. So knowing that, we can actually create a function or create some code that will tell us the distance between 2 objects. Let's go do that now. I'm going to put it probably under all of this stuff here, and I'm just going to call it a helper function for finding the distance between 2 objects. So we're making our own function, and we'll be able to call it, and we're going to give it the x position of the first item, like the player, for example, the y position of the first item, the x position of the second item, and the y position of the second item. Now, as we just talked about, A you can find out by having the second x position minus the first x position, B by having y2 minus y1, and then C, using Pythagoras' theorem, is the square root of a squared plus b squared, okay? And then we can just return C, okay? Now, again, if that doesn't make a huge amount of sense, don't worry, don't panic. You can copy that out. I probably will put that in this function into the description of the video as well, in case you just like to copy it, copy and paste if you wish, but I just wanted to go over and explain sort of how it works. Okay, so now we can use that function, and what we can do is we can actually go and check if a collision is happening each frame. I'm going to do that here in the draw function that runs 60 times a second. So 60 times a second, we'll check for those collisions. So I'm going to put a comment, check for collisions, and we want to say if the distance from, well, mine is actually player, So player X, player Y, moon X, moon Y. We could have done it the other way around. We could have said moon X, moon Y, player X, player Y. Doesn't matter. The distance between them will be the same, no matter which direction it goes. If it's less than 50 pixels, and you can play around with that number and see if it works for you. All right, what do we actually want to happen if we hit the moon? Well, what I would like it to do is actually go and disappear and end up in a different random position. So the way we get a random position is we're going to have to go to the top here and import the random module, because it doesn't come built into the base Python. And then I will copy and paste this to make it a bit quicker. We can set moon1's X position to a random.rand range between 0 and the width and 0 and the height for the Y position. So that'll appear randomly somewhere on the screen. Let's see if that works here. Oh, actually, sorry, we use the math library too, so we'll have to import the math as well. There we go. Okay, so let's go and check. Okay, so that one we haven't done yet. This one though, if we touch it, it should go and land in a random spot somewhere as well. Okay, now the way that I'm actually going to set my particular one up is I want both of the moons to reset when I touch either of the moons. And so the way that I'm going to do that is I'm going to say here, I'm going to copy this. So I'm going to say if the distance between player and moon 1 is less than 50, or if the distance between player and moon 2 is less than 50. So either one of those things happens, then we're going to reset the position of moon 1 and the position of moon 2. But you can set yours up so that they're separate if you wish. You should be able to work out how to do that, and if you can't, I'm happy to help. So now if we hit run, when we touch either of them, both of them should disappear. Now, just for a little bit more realism, I would like to reset the rotation of them as well, because if we reset the rotation, it sort of gives the impression that it's a new moon rather than just recycling the current moon, which is really what we're doing. So moon1.rotation equals, underscore rotation is 0, and moon2 underscore rotation is 0. Okay, and now we've got our collision detection working. So we can now go across and get the closest moon each time, but there's really no point doing this because we don't have a score and we don't have a timer. So let's get those things up on the screen up there, and hopefully it'll make the game a little bit more interesting. The best way to do a score, I think, is just have a variable. I'll put it here somewhere. So I'll have a variable for the score, and we'll set that to 0. And I'm also going to have a variable for time passed, and we'll set that to 0 as well. Okay, let's do the score first. So we want to modify the score in here. So I'm going to add in the draw function, we want access to the score to change it. And here, every time we have a collision, we not only want to set them to a random position, but we want to increase the score by 1. So score plus equals 1. That will increase the score by 1. And again, the score is just a variable name that I've come up with. You could call it points or something like that. That's fine. Score plus equals 1. And also, just to test, let's print the score each time so that we can see if that's working. Okay, so I'm going to go over here and 2, 3. Hopefully there's 1, 2, 3 written over here in our output, and there is. Okay, so the next step is to get that score drawn onto the screen. I'll get rid of that print statement. Now, I want the score drawn on top of everything. I don't want it to go behind players or moons or anything like that. So let's say draw score. Okay, and again, you can go and look in the documentation to see how to draw text on the screen. It's in the graphics modules, and I think it is in Oh, I had to pause there and search for a while. It's in Canvas. Okay, so canvas.drawText, and I'll show you all sorts of examples in there. I just paused the video and typed it in just to save a bit of time. But if you go canvas.drawText, the text that I want is the word moons, and I've got quotation marks around that. In Python, it doesn't matter whether they're single or double quotation marks. It could be like this as well. But basically, if you get a string and then you add it to another string, now score is actually a number, so to turn it into a string, you type str and put it in brackets. That will convert it to or give you a copy back that is a string. And if you put a plus between two strings, it just joins them together left and right. I want this to be at an exposition of 500, sort of just past the middle, and because I want the timer to be on the left, and you'll see that in a minute. This is the size of the text, this is the color, and this is the font. Now, sans serif just means it doesn't have those little extra little embellishments around the edges of the letters like on Times New Roman and things like that. Okay, let's have a look at that. And as you can see here, it is up there, and every time I select or catch a moon, it goes up. Now, let's do the timer. So the timer, we've already got a variable here for the number of seconds passed. And what we can do, again, this is in the documentation, but I'll show you here. You can actually, remember this code down here is not inside a function. So this code here will all run instantaneously at the start of the program, and it's just setting things up. So at the start of the program, we want to add a timer. And again, you can call it whatever you like. I'm just calling mine timer to make it easy. Simple GUI.create timer. I want it to fire off this function. A second has passed. That's what I've called it. I made that name up. Every 1,000 milliseconds. So every second, I want it to run a function called second passed. And then I want the timer. So this sets it up, ready to go. And then I want the timer to start at the start of the program. Okay. So remember, this code all gets triggered at the start of the program. It's just setting things up, starting them, etc. Okay. So that means then that we need a function called second passed. And again, I'm going to copy that just to be a bit quicker. So in our handlers here, this function will run every time that timer triggers, every 1,000 milliseconds. Now I want access to the time passed variable to change it, and I'm just going to add 1 to it each second. Okay, and we can test that out by saying print time passed, and just see that that actually is working in the output there. Yes, that looks correct. And I don't need it to be absolutely perfect. If it's a couple of milliseconds out, then it's not the end of the world, but we just do the best that we can for this game. Okay. Now we'll want to draw that text as well. So I'm going to say draw timer and score, and then I will add on the code. I'm going to put the timer code above the score code here, because I'm doing the timer on the left. That's just, it makes no difference, but as you can see here, the time will be here and the moons will be here. Okay, yeah. So again, we're joining the word time with taking the time passed number and converting it into a string. Okay, and we're doing that at the same Y position on the screen, but earlier on to the left in the X position. Same size, same color, same font. Okay, so that's the code, and this should be the result. Again, you can choose different fonts, different position, different colors, If you want to get a good color, you can go to Color Picker online, copy the hex number from that and paste it in if you wish. But I'm just going to stick with simple things.